If you like these videos, you can easily support this channel by subscribing, by liking the video, and by leaving comments. Feel free to ask any questions you have or suggest videos you'd like to see in the future. Thanks for the support. Hello, in this video, we will be covering React Native. Here is the list of topics that we will be covering in this video. You can also click on the time links in the description below to jump straight to a specific section. We're going to be moving really quickly, so feel free to pause or replay the video if you need to. So first, what is React Native and what are some of its highlights? Well, first, React Native allows us to develop apps for mobile phones. Second, React Native allows us to use JavaScript for both iPhones and Android phones, which saves a lot of time and money. Third, React Native actually produces a native mobile app, and not just a web app that can also be used as a mobile app. Fourth, React Native has very similar syntax to React, so it's really easy to learn. Now, let's just get right into installing and using React Native. To install React Native, we can simply follow these instructions on the Getting Started page in the React Native docs. Before you begin, you will need to have Node installed, so if you don't have that, you should first go to nodejs.org and download Node. So, let's just follow these instructions and do npm install-g create React Native app, which will help us easily create a starter app for React Native. Then let's do create React Native app, React Native tutorial, and let's wait for that to finish installing. Then let's cd into React Native tutorial, and then let's do npm start, and we'll wait for this to finish. And now we see a QR code in our terminal and some instructions below the QR code. Next, let's learn how to view our React Native app. We can either view it on our phone or we can view it on our computer with a simulator. Let's first learn how to view the app on our phone. The instructions here tell us to install the Expo app on our phone, so let's go ahead and do that. If you have an iPhone, it'll be in the App Store, and if you have an Android, it'll be in Google Play. After you install and open the app, here's what it should look like on your phone. Then we just press Scan QR code and then scan the QR code that's in the terminal. And we'll see that the React Native app opens in our phone and we see this boilerplate text here. Next, let's learn how to view the React Native app on our computer. This may be a little more complicated and the instructions will be different depending on if you are on a Mac or on Windows, and depending on if you want to run a simulator for an iPhone or an Android phone. On the React Native docs Getting Started page, click on the tab Building Projects with Native Code. Then select whether your computer is Mac or Windows and whether you want to run the app on iOS or iPhone or Android. Then just follow all the directions below for setting up a phone simulator on your computer. I'm using a Mac, so I needed to install Node and Watchman, install the React Native CLI, download Xcode, and I needed to enable the Xcode CLI. If you want to run your app on an Android, you'll need to download Node, Python, and the Java Development Kit, or JDK, then install the React Native CLI, and then set up the Android development environment by following these directions below. Then, after you finish following these instructions, you can either do from the terminal React Native run iOS or React Native run Android, or you can do npm start, and then just follow the instructions in the terminal and press the letter of what you want. So, in my terminal, I'm just going to press the letter I for iPhone, wait for that to load, and you'll see that the app opens on a simulator on my computer now, with the same boilerplate text that we saw on our phone earlier. Now let's open up the code. So I'm going to cd into the directory like this, and then I'll open it up with my text editor, which is Sublime Text. And then let's open up the app.js file. Now let's take a look at some of the code differences between React Native and React. First, instead of using normal HTML elements like divs, React Native uses specific components from the React Native library like view and text, which we see here. These components are basically JavaScript equivalents of what would be the native code for iOS or Android. Also, styling components is different. Instead of using CSS, we have pure JavaScript here that simply looks a little like CSS. We don't get all of the CSS properties, but we do get many of them. We'll talk more about styling with React Native later in this video. Other than these two things, the code for React Native looks a lot like React. We have props, state, lifecycle methods, and components, just like in React. If you haven't learned React yet, it would be a good idea to first go through that tutorial first before going through this tutorial, because there are some concepts in React that will apply here too, such as lifecycle methods. Next, let's talk about props. Just like in React, React Native components accept props. For a full list of what props each React Native component accepts, the best place to go is the React Native docs right here. And just like with React, every component can take a style prop for inline styling. And let's just take a look at one more example for now. Let's import a switch component, and then let's add the switch component at the bottom here. And you see that this switch component now shows up in the simulator. If we click on it, the behavior is kind of broken. Now let's just try to add a few props to this component, and we'll do a little more with it later. We'll talk a little more specifically about the switch component later also. Let's first add a value equals true, and then we'll see that the default switch now is on. Then let's just try another prop. Let's do disabled equals true, and now we see that the component is no longer clickable. And we can actually get rid of these equals true here because the default value of a prop is true, and everything still looks as it did before. Now let's talk about state. Managing state in React Native is pretty much the same as in normal React. To start us off, let's create a constructor method up here with props, and then super props, and then let's do this.state equals value and then false. Then let's change the value in the switch component to be equal to this.state.value. Then let's get rid of the disabled prop. Then let's add a prop called onValueChange, which is going to be called when the switch component is clicked. And then let's just set that equal to a function that does setState and then sets the value to the opposite of what the value currently is. And now you'll see that when we click the switch button, it works properly now because each time we click it, the value in the state is being changed back and forth from true to false. Next, let's learn about the view component. For all of these components that we'll be covering in this video, you can go to the React Native docs and click on the component in the left sidebar for a full list of the props that are available for each component. We'll just be covering some of the basics in this video. So the view component is basically a generic container that supports styling and some touch controls. As you can see here, there's already a style prop on this view component, and the styles are defined below in the StyleSheet API. We'll cover more about the StyleSheet API later in this video. For now, let's just try changing the style of the view in a few different ways. First, let's change the background to green, and we'll see that the screen turns green. Then let's try taking out the flex 1, and we'll see that the view no longer fills the screen. Then let's put the flex 1 back, and let's try taking out the align item center now. And we see that the content of the view is left aligned now. Then let's put back the align item center and take out the justify content center, and we see that the content of the view is now aligned at the top. And now let's just change the background color back to white. Next, let's learn about the text component. The text component supports nesting, styling, and touch handling. Let's play around with it a bit by first getting rid of everything in here. And let's just have a text component and a closing tag. And then let's first just put hello in here, and we see that it displays on the screen. Then let's try nesting a text component with style and color red. Then let's add the closing tag. And then let's put in here Michael, and now we see hello Michael, and Michael is red. Now let's learn about images. Notice that it says here that for network and data images, you will need to manually specify the dimensions of your image. So in most cases, we need to explicitly set the exact height and width of the image. This is because of display and performance reasons. So now let's try adding an image by adding the image component to the imports above. Then let's replace the contents of the view with just an image component. And then let's just copy this sample code here, which has a prop of source and inside an object with a URI property with the value of a URL of an image. And let's multi-line this component and then paste this code here. And you'll see that when we save, nothing shows up on the screen. That's because we need to set a height and a width for the image. So let's add a style prop with height 50 and width 50. And now when we save, we see that the image shows up properly on the screen. Now let's just play around with this a little bit and change the height to 150 and the width to 150. And we see that the image is larger now, although a little blurrier because this isn't the optimized size for the image. And if we change the height to just 50, we'll see that the image doesn't show up in a proper size anymore. Next, let's learn about text input. There are several special props you can pass into text input, such as auto-correction, auto-capitalization, and different keyboard types, such as a numeric keypad. Text input also has all of the methods that a traditional input element has, such as onChange, although the one that we should probably be using here is onChangeText. It has onFocus and onBlur. Now let's just play around a little bit with the text input component. So let's add text input to the imports at the top. Then let's replace the view with the text input component. Then let's add a placeholder that says type here. So now we can see the text input with the placeholder type here on the screen. Then let's change the state to have value hello. And then let's set the value of the text input to be this.state.value. And we'll see that the input on the screen now has the default value of hello. Next, let's just display this.state.value below so we can see the onChangeText prop work better. Let's do text, then this.state.value. And then let's close the tag. Then let's add onChangeText up here. And then a function with text, ES6 double arrow syntax, and then this.setState, value text. So now when we change the value in the text box, we see that this.state.value changes correctly also. Next, let's learn about ScrollView. ScrollView should be used when you have content that won't fit on a single screen, and you will need to scroll to see all of the content. ScrollView renders everything inside of it all at once. So if you have an enormous amount of content that you need to show, such as a really long list, you should use FlatList or SectionList instead, which renders things more intelligently for performance. So for ScrollView, there's a note here that we should make sure the parent has a bounded height. Our view here has flex 1, so it has a bounded height. Next, let's just delete everything except for the text component here, and then let's add some styling so that the content of the view doesn't all fit on the screen. Let's add style, styles.text, and then below let's add a text property with styles, background color, yellow, margin top 300, and margin bottom 300 to make it really big. And then let's just copy the text component line and paste it 3 more times, so we have 4 of them now. And now when we save, we'll see that we can't scroll to see the content that's currently below the screen. So let's now use ScrollView to solve this problem. Let's add ScrollView to the imports at the top, and then let's put a ScrollView component right underneath the view. Let's close the tag, and then let's move the 4 text components inside the ScrollView component. And now when we save, we'll see that we can now drag to scroll down and see all of the content. But you'll see that things look weird because the scroll bar is in the middle of the screen. To fix this, we just need to get rid of the Align Items Center style below, and now you'll see that the scrolling behaves as we expect. Next, let's learn about styling with Flexbox. Flexbox is a really powerful tool for styling, so it would be a good idea to become familiar with how it works. On the React Native docs, on the Layout with Flexbox page, it says that you will normally use a combination of flex direction, align items, and justify content to achieve the right layout. Now let's take a look at these Flexbox properties. First, let's make this style prop an inline style with background color yellow. Then let's replace the 3 text components below with this top text component. Do some reformatting here. And then paste 2 more times. And then let's change these colors to be blue, green, and red. Let's save, and then we'll see the 4 colors on the screen. Then let's add a flex 1 to each of these text components. And in order for this to work, the parent component also needs to be a flex component. So let's delete the ScrollView component so these text components have the view component as their parent. Now we'll see that each of the text components take up an equal amount of space on the screen. So what's going on here? Well, flex 1 basically says that the component should fill up the available space on the screen. The view component has a flex 1 property, so it takes up the entire screen. Each of the 4 text components have flex 1, so they each fill up 1/4 of the screen. The default flex direction for React Native is column, which is why we see the 4 text components lined up vertically like this. The default flex direction for normal CSS is row, which we'll experiment with a little later. Now let's try changing the flex in the blue component to be 2, and now we see that the blue component takes up twice as much space. Flexbox makes it really easy to have perfectly proportioned sections by using the numbers for flex in ratios that we need. Let's just play around with this a little more. Let's try changing the blue component to be 3, and we see that the blue section is even bigger now. Now let's change flex direction to row and see what happens. Let's delete the justify content center here, and then let's add flex direction row to the container view component. And now we see that the 4 text components go across the screen horizontally instead of vertically in the same ratio as before. Now let's learn about align items. Let's add align item center to the container style. And now we see that the 4 text components are aligned at the middle of the screen. Align items will align the child components along the opposite axis. So since the container component has flex direction row, align items will align things vertically. Now let's learn about justify content. First, let's remove the flex properties from each of the text views above so they don't fill up all the space horizontally. Then let's add to the container styles justify content center, and we'll see that the 4 text components are now centered horizontally on the screen. Justify content aligns the children along the same axis as the flex direction. Some other useful justify content values to try are space around, which spreads out all the children evenly, and space between, which keeps the first and last children at the 2 ends of the screen. Now let's just see what this looks like with the default flex direction. So let's delete this line, and now we see that the 4 text components are stacked in the middle, both vertically and horizontally. And if we take out the justify content center, they will be at the top of the screen as we expect. This is just an introduction to Flexbox. You can accomplish most of what you need to do with the information I've just given, but there are other Flexbox properties that can be useful to know. So I would recommend studying it more if you run into problems that these properties can't solve. Next, let's learn about the button component. One important note about the button component is that it supports a minimal level of customization. So if you want a button that looks or behaves differently from this button component, there's a touchable opacity component that you can use, which we'll cover next. So now, let's take a look at the basic button component. First, let's add to the container style the property justify content center to center the content in the middle of the screen. Then let's add the button component to the imports at the top. Next, let's get rid of these 3 extra text components, and then let's add a button component with color red, title, press me, and an onPress prop that's a function that does this dot set state value goodbye. And we need to close the tag here. And now you'll see that when we press or click the press me button, the state value changes from hello to goodbye. Next, let's learn about the touchable opacity component. Touchable opacity allows us to turn basically anything into a button. Let's try it out by first adding touchable opacity to the imports at the top. Then let's delete the basic button component here. And then let's add the touchable opacity component here. And then let's close the tag. And then let's just add the same onPress prop that we did before, which will be a function that does this dot set state value goodbye. Then let's add some styling to the text component below. Let's say padding 50. And then let's move the text component into the touchable opacity component. And now we can press or click on this text component and the state value changes to goodbye, just like with the basic button. Also, notice that when we press the button, it automatically changes opacity, which creates a good user experience. The advantage to using touchable opacity is that you can make the button look however you want. Next, let's learn about the picker component. It renders the native picker on iOS and Android. Let's try it out by first adding picker to the imports at the top. Then let's just copy this sample code here. And let's replace the entire contents of render with this code, since it seems the picker component can't go inside of a view. And when we save, we now see a picker on the phone, and we can change between Java and JavaScript. Now let's just play around with this a little bit. Let's change the state to be language.js, and now we see the default value of the picker is JavaScript instead of Java. We can also easily change the labels and values, and we could add more options. Next, let's learn about the slider component. Here is the list of props that are available for this component. First, let's just replace the render with view, style, styles container, and let's close the tag. Then let's add slider to the imports at the top. Then let's add the slider component inside the view component, and we'll see something show up on the screen, but it doesn't look right. So let's remove the align item center, and we'll see that the slider shows up properly now. Now let's change the state to have a value of 1, and then let's add to the slider component a prop of minimum value 1, maximum value 100, and on value change, and it'll be a function that takes a value and does this.setState value. Then below the slider, let's just display this.state.value. And we need to support this with the text component. And now we see that as we drag the slider, we see the value of the state and slider change below. Now let's learn about the switch component. We've already done a little bit with this component, but let's just officially cover it here. First, let's replace the contents of the view component with the switch component, and as we saw earlier, it doesn't work correctly. That's because there's no value set on it, so it keeps changing back to undefined or false. So let's fix this by adding a value equals true, and then an on value change equals, and then a function that does this.setState value, and then the opposite of this.state.value. And let's actually use state here, so let's set the state to be value true, and then let's make the value of the component to be this.state.value. And now when we click the switch component, it works correctly. Next, let's learn about the FlatList component. The docs say that this is a convenience wrapper around virtualized list, which allows us to render very large lists in a way that is performant. It only renders what's in view, so we don't waste time rendering things that are out of view. This also means that sometimes when we scroll quickly, we might need to wait for things to load first. So let's learn how to use the FlatList component by first copying this sample code here. Then let's add the FlatList component to the imports above. Then let's replace the contents of the view component with the code that we just copied earlier. The list items are now at the top left, but we can barely see them. So let's just make these keys a little bit longer with some garbage text. Then let's add to the text component here style and styles text. And now we can see one of the list items better on the screen. And we can also scroll down to see the second list item. And with FlatList, the render item method will usually be a separate method defined on the React component instead of completely contained in the FlatList component. So let's add a render item method up here, and it takes an object with item as one of its properties. Then let's do return. And then let's just copy this text component down here and paste it into the return statement above. And let's make the render item method a little more robust actually. So let's create a view component here that we will put everything into. Let's create a closing tag. And then let's do some reformatting to the data array here. Let's multi-line the objects in this array. Then let's add a name property to each of these objects and also an age property. The names will be Michael and John, and the ages will be 30 and 28. Then let's move the text component up here into the view component, and let's change item.key to item.name. Then let's copy and paste this text component line, and let's replace item.name here with item.age. Then let's replace the contents of this render item prop down here with this.render item. And now when we save, we'll see Michael, 30, John, and 28. So we see that we can add whatever properties we want to the data array, and we can render them however we want also. Now let's learn about the SectionList component. This component is similar to FlatList, except it allows us to render sections or groups of items. To use it, let's first add SectionList to the imports at the top. Then let's replace FlatList here with SectionList. Then let's get rid of the styles for the text components up here. And let's add a render header item prop here, and it'll take an object with section. And let's just render a text component with section.title inside, and let's close the tag. Then let's change data to sections. Then let's update the sections prop by first copying the array that we currently have in here. Then we'll do data, then paste the code that we just copied. And this should all actually be in an object. And let's add a title here that says section 1. Then let's copy this first object and paste it below. Let's change the title below to be section 2. And this second section should actually also be in an object. And now when we save, we'll see the two sections, each one with a section title and contents with the name and age. Now let's just add a style to the header here of styles.header. And then below, let's define the header style as having color, red, and margin top 200. So now we can differentiate between the two sections better. And now let's just add a third section by copying the second section here, pasting it below, and then changing the title to be section 3. And now we see that our section list is scrollable. There's a little bit of funkiness here with the style, but this is basically what we expect. Next, let's learn about the StyleSheet API. StyleSheet is a JavaScript implementation of something that is similar to, but not exactly, CSS style sheets. In CSS, we could do something like background yellow, but we see that this fails with style sheets. And in the error screen that shows up, we get a list of properties that are supported by style sheets. And we see here that only background color is supported, not background, so we need to change this property to background color. And now we see that everything displays properly again. We can also style components with inline styling, so we could put up here on the view component style equals background color green. And we see that the style is applied to the view. Now let's just revert everything back to the way it was. So let's delete this here, and then delete this down here. Next, let's learn about debugging in React Native. We can press Command D or Control D on Windows to go back to the Expo home screen, and then we can click Debug Remote.js, which will open a new tab in the browser. In this new tab, we can open the Chrome Developer Tools console by pressing Command Alt-J on the Mac or Control-Shift-J on Windows. And I'm going to click Reload JS Bundle here to refresh everything. Then we can see the console logs that we put in the React Native code. Let's try it out by adding a component didMount method here. And then let's just console log in here, mounted. And we see that mounted is logged to the browser console. Back in the menu, you can also click Toggle Element Inspector, and then now we can click on the elements on the screen to see information about them. So I can click on the header here, and I'll see some information below that could be useful for debugging. I can also click on a list item or on the entire section here, and we can click the option here again to turn off the remote debugging. And we can also turn off the element inspector like this. Now let's learn about platform-specific code. There are times when we will need to write code that is specific for either iOS or Android. There are some components and APIs for React Native that are exclusive to either iPhone or Android, and sometimes we will need or want to style things differently depending on if the app is on iPhone or Android. To figure out which platform the user is on, let's first enable the debug remote.js. Then let's add platform to the imports at the top. Then let's remove this code in component did mount. Then we see in the docs here that we will use platform.capitals to determine which platform the user is on. So let's console.log platform.os, and we see that iOS is what shows up in the console since I'm using a Mac. If I was on Android, it would have shown that. So we can use the value of platform.os to create conditional statements that are specific to iOS or Android. For a list of platform-specific components and APIs, we can click on the Components and APIs link here, and then scroll down like this, and we can see that there's a section for iOS components and APIs, and a section for Android components and APIs. Next, let's talk about other components and APIs that are available in React Native. There are many other components and APIs that we could use and learn to use. If we scroll down here, we'll see a list of some other popular components and APIs. Also, for a full list of the components and APIs that are available, you can look through the list in the left sidebar of the React Native docs. Next, let's talk about making HTTP requests in React Native. React Native has fetch built in, and this is usually how you will make HTTP requests. To try it out, let's just copy this simple fetch request here, which is a GET request. Let's replace the code in component did mount with this code, and let's console log the response.json. And we see in the console that we successfully received a payload from the URL that we made the request to. We can easily make other kinds of requests by using the second parameter of fetch. We see here that we can change the method, we can add headers, and we can send a payload with body. To use React Native with your own server, your server will need to be an external URL, and you will make your fetch request to your server URL. Next, let's learn how to do animations in React Native. To start us off, let's just first copy this sample code here, and then let's replace the entire app.js with this sample code. Up here, we have a fade anim property, and then in component did mount, we are changing the value from 0 to 1 over a period of 10,000 milliseconds, or 10 seconds. And down here, we are setting opacity to the fade anim property in state. Let's save, and now we see a button that fades in really slowly, across 10 seconds. Now let's just play around with this a little bit. Let's change toValue to 300. Then let's change fade anim to top anim. So we're going to change the top property now. And let's change the opacity down here to be top instead. And now when we save, we'll see the button move down the screen slowly. Now let's try speeding up the animation. Let's change the 10,000 here to be 200. And that was too fast to see, so let's change it to 2000. And now we can see the animation move faster than the 10-second version. And let's just try changing it to 3000 also. And now it animates just a little slower than before. Next, let's learn how to do navigation with React Native. It says in the docs that a popular solution is the React Navigation package, so let's try that. Let's follow these instructions here. Let's do npm install -- save React Navigation. Then let's do import stack navigation from React Navigation. Then let's copy this code in the docs here. And let's first replace all of this in app.js with this sample code. Then let's do export default app. Then let's copy the code for the home screen component in the docs right here. And then let's paste that above the code that we just pasted. Then let's paste this same component again below, and let's change it to Profile Screen. And let's change the title up here to be Home, and the title down here to be Profile. Then let's change the navigate down here to be Home, and let's change the title here to be Go to Home. And this should actually be Stack Navigator up here, not Navigation. And now we can click on this link to switch between screens, and you'll see that it animates nicely. We can also click on the back button to go back to the previous screen. And let's just play around with navigating to different screens for a little bit by clicking these buttons here. Next, let's learn how to deploy our React Native app to the App Store and Google Play. The key is just to know where the instructions are in the React Native docs, since it might not be obvious. To deploy to the iOS App Store, click on the Running on Device link in the left sidebar. Then scroll down to the Building Your App for Production section and follow these instructions here. You will need to have an Apple developer account to submit an app to the iOS App Store. To deploy your app to Google Play, click on the Generating Signed APK in the left sidebar, and then follow these instructions here. They're pretty detailed and thorough, so just make sure you follow the directions carefully. And that's all for this tutorial. Hopefully you found it helpful. I'll see you next time.